Tomorrow in class, we're going to learn how to use the calculator to create a table. Sometimes it's easier or just as easy to tell the key features of a function with the table as opposed to making the table and then drawing the graph. On the EOCT, you're not going to have GeoGebra or those types of tools to graph for you, so you might want to see if you can figure out how to identify these key features without actually having to go through and draw the graph, although drawing the graph will always work. The first key feature we want to talk about is the x-intercepts. Now remember, the x-intercepts are always found on the x-axis. It's the point where the graph crosses the x-axis, which in this case would be at -2 and at +2. Now we can tell the x-intercepts in the table because the point is the -2, 0, which would be here, and +2, 0, which would be here. Notice both of these have 0 as your y-coordinate. That will always tell you that your x-intercept is those points. Your x-intercept always has a 0 as your y-coordinate. So you can look at the table and find the 0 in the y column, and those are your x-intercepts. The next key feature we want to identify is the y-intercept. Now we know that the y-intercept is the point where the graph crosses the y-axis. So in this case, it would be at -4. If I find the corresponding point in my table, that would be 0, -4. My y-intercept always has an x-coordinate of 0. So if you simply look for the x-coordinate that's 0, then you can find your y-intercept. So the x-coordinate will be 0 for the y-intercept. All right, next we want to talk about the interval of increase. Now you read a graph from left to right just as you read a book. All right, so if we read the graph from left to right, we notice this graph decreases. It reaches its lowest point and then it begins to increase. So our interval of increase would just be where the graph is increasing, which would be right there. All right. So if we use our table and we go and we look at our function values, from 5 to 0 is decreasing, from 0 to -3 is decreasing, from -3 to -4 is decreasing. But then my function begins to increase because from -4 to -3 is increasing, from -3 to 0 is increasing, from 0 to 5 is increasing. So my interval of increase will begin at 0, -4, and it would it would continue to increase. So my intervals of increase would be starting at the x value 0 and going on forever. So the table, it gives you a handy way to show where it's increasing. All you have to do is look at the y values and find where they begin to start increasing. The same way for your intervals of decrease. Again, as you trace the graph, I notice that it's going down, down, down until your lowest point, which is called your vertex, and then it begins to go up. So those are that right there is a pictorial view of your intervals of increase or decrease. Again, as you look at your function values, I notice I go from 5 to 0, which would be a decrease. I go from 0 to -3, which is a decrease. From -3 to -4, which is a decrease, and then it begins to increase. So my intervals of decrease, in this case, would be from the smallest negative number you can get all the way to 0, because once it's 0, it stops decreasing. All right, next we want to look at our positive function values. We know from our graph that the positive function values are the values that are above the x-axis. So they would be all the values on this side of the graph and all the values on this side of the graph. It's really easy to find them in your table because, again, you're looking at your function values. So you find the numbers in the y column that are positive. So that would be these numbers and these numbers. So any x value that is above 3 or above is going to give you positive function values. Here we're looking for negative function values. Again, remember, negative function values will be all the values that are below the x-axis. If you look in your chart, you're simply looking in the Y column to find negative values. These would be my negative values. So this would be my intervals that my function would be giving me negative values. Now we're looking for our minimum or our maximum. We know how to locate that on the graph. That would be the lowest or the highest point. In this case, that would be that point right there. And if you look at, again, your function values, all right, they decrease from 5 to 0 to -3 to -4. -4 would be my lowest functional value because, again, it begins to increase there. So this would be, since this is the lowest point, it would be called a minimum. If it was the highest point or the largest value in the function column, it would be called a maximum. And then your axis of symmetry. Remember, your axis of symmetry is simply a line that divides that parabola or quadratic function into two identical sections. All right, so we knew we draw the line in the picture. But you can also find that from the table. All right, remember, symmetry is like a mirror. All right, notice I have a 5 and a 5, a 0 and a 0, a 3 and a 3, but I only have one 4. That is going to be where your axis of symmetry is, and you use the x coordinate, so I would say it's x equals 0. I have to use my y values or my function values to find the symmetry, but wherever my symmetry ends, my x value is my equation for my axis of symmetry. We'll be working on this some more tomorrow and using the calculator to make these tables and see what we can do about identifying the key features.